Hello and welcome. Today we'll be going through the OptiAssist for Simcenter3D tutorial 1, the gauge optimization of a trolley. Here I have the file already loaded. You will find this file in your GRM folder, OptiAssist for Simcenter3D 308, latest iteration, examples, thickness optimization, tutorial 1, and you want the sim file. It is recommended that you copy the initial GRM file to a new folder so that when you are working you have full writing permission. The first thing we are going to do is run a simple analysis. Just click no, cancel, close, and take a look at the results just to give us an understanding of what's gone on with the initial analysis. So taking a look at the displacement, here we can see the maximum displacement at the handles is 3.9 millimeters, and then for the barrel pushing down the plate, that's around 1.2 millimeters. Once you're happy with that, we're going to click Return to Home, and we are going to select the OptiAssist tab, which you should have as the add-on. If you can't find the OptiAssist ribbon, you'll need to contact your IT department or check the installation. From here, we're going to Thickness Optimization, which opens up the optimization setup window. First thing we're going to do is click on Handle Load, holding down Shift, 3G bump. First thing we're going to do is click on Thickness Optimization, which opens up the optimization setup window. The first thing we're going to do is select the subcases, so I clicked on Handle Load and then 3G bump and click Next. This opens up the Design Rules tab where we will create two new rules. So clicking on New, we'll name this one Pipes, with the minimum being 1.6 mil and the maximum 4.0 mil. Listing the properties by name, we can select all the names with pipes in them. So click on the first one, click on the last one, holding down Shift, and then Adding Rule. And now we just need to repeat the process. So this one will be called Sheets, with the minimum being 1.2 and the maximum being 5.0. So go and click OK, and click on the properties of sheets in the name and clicking Add Rule, and you can see the rules have been added there. Click Next. Here we come to the Goal tab. Here we want the goal type to be Maximize Stiffness. We want it to be the design properties, not including the barrel. Get current mass, 17.5, that is correct. And again, selecting the subcases. Click on Next. No further constraints are required, so just click Next again. And this brings us to the Settings tab. All the default settings are absolutely fine for this optimization. Therefore, we'll click OK. Refer back to our OptiAssist tab and hit Solve. Once the solution is ran, you can click No, close, and the first thing we're going to do is take a look at the design history. First thing we're going to plot is the objective, and here we can see the design objective representing the compliance has decreased throughout the design cycles. So we know the optimization has worked. We can also check the constraint violation. We can see that it started at 0 and remained at a low enough number for it not to be a concern. Let's click Close, Another way of understanding the change in design is to plot the thicknesses from the optimization. To do this, we go to the OptiAssist ribbon and under Post-Processing, click on Thickness Contour. Latest cycle, and click Plot. This shows the new thicknesses added to the different components of the model with a scale showing that the darker blue colors, such as the pipes, have a slight increase in thickness, whereas the plate and the handles have a much higher increase in thickness from the optimization. Once you're happy with that, we'll close the window, and here we can now take a look at the new results. So under OptiAssist Solution, Structural, Latest Design Cycle, Displacement, Magnitude. The maximum displacement has gone from 3.9 to 3.3. So we know the optimization has actually worked for this model. Once you're happy with that, we're going to click Return to Home. If we go to the OptiAssist ribbon and click on Update Model, reload the results, we need the latest cycle, we change the thickness tolerance to 0.1 and click OK. Yes and yes. Once you have done that, if we switch back to the F file here, highlight the 2D collectors and all of its components, right click and plot thickness contour, we can now see the new thicknesses added to the model. This concludes the tutorial.